Good evening, everyone. How are you doing tonight? I hope you had a good day, not too busy. And I hope you do have some energy left for me. So busy. Yeah, me too. Me too. It's always busy, right? The beginning of this new academic year. This is where you need to find your new routine. There is a lot of paperwork and organization and meetings, things to set up. So yeah, it is quite busy. But at least I hope that this, it's good to be busy, and I kind of enjoy this the beginning of these school years, because yeah, it is the time where you meet new students. Everybody is motivated. They wanna do well. Sometimes it goes downhill afterwards, but at least at the beginning of the school year, it's usually pretty nice. The exams are still pretty distant in the future, so there is not too much pressure. You get to work with new colleagues. So yeah, it's usually pretty exciting. All right, so tonight we have again we have a busy schedule, but the workshop is not going to be as technical and tedious as last week. Last week we talked about consumer equilibrium and the decomposition of a price effect, and there was a lot of content. So thankfully we have the video recording, so you can watch the workshop again in case I went too fast on some topics. Tonight we need to talk about production theory, which is a topic that I have divided into two chapters or two PPTs, one for each time period, because the way firms make decision is actually quite different. So first we will look at production in the short run. That's going to be the first PPT. And second, we will have a look at production in the long run. And before we start, I have to apologize because I did not have time to finish preparing all the materials. So the PPTs are ready, and I have already shared them, even if there are still a few things that I would like to modify about production in the long run. Production in the short run is fine, but I haven't found the time this week to prepare the summary, the definitions. So this is something I'm going to work on probably on Thursday, because tomorrow I have to work on the AS workshop. Yeah, it's a just-in-time process. All the resources that I share with you guys are specifically created for this workshop, or for this series of workshop. It's something new that I have developed this year. So yeah, sometimes it's a bit difficult to find the time to make sure that I can share with these resources with you on time. But yeah, you will have everything in a couple of days, so that should be enough. But again, I apologize for not uploading everything before the workshop. Speaking about the website, you probably realize that now I use a different provider to host the videos. I used to host the videos myself, but the problem is that it was sometimes very slow to load, extremely slow sometimes. So now I am using Vimeo. So the advantage is that it's much quicker to load. The disadvantage is that you need a VPN. All right, so if you do not have a VPN, you will not be able to watch the video recording for now. I don't think that's a big issue, because I assume most of you already use a VPN. But if you have any problem, if you have any issue to access and watch the video recordings, then please send me a message and I will walk you through the process of watching the videos without a VPN. It might be slow, but it will be working. Okay, so if you have any issue, please send me a message. Okay, are we ready? Let's get started, and let's talk about production theory. So let me share my screen. We'll start with production in the short run. Let's go. Okay. So the first thing that we have to discuss is this concept of short run and long run. But in A2, they should already know what this is, simply because it is already covered in the first chapter, actually. And for those who have attended the AS workshop, was probably a couple of or 3 weeks ago, I have already talked about this different time periods, short run, long run, and also the very short run and the very long run. So that's why if you look at the PPT, I have added the reminders sign there just to emphasize that this is not something new. This is something that they are expected to know. All right, so I'm not going to spend too much time on this, but yes, in production theory, there are typically 4 different time periods: very short run, long run, very long run. But in A2, we are not very much interested in the first one and the last one. We mainly focus on the short run and the long run. So yeah, let's just focus on this. And yes, generally speaking, it's about flexibility. Okay, it's about in the short run, you don't have much flexibility, but in the long run, you gain flexibility. That's essentially the difference for the business. Flexibility in terms of what? So in production theory, this is flexibility in terms of inputs, in terms of resources. We have the ability to change the quantity of a resource or a factor of production that we use. Right? That's about it. Yeah. So essentially, something that is fixed in the short run can become variable in the long run. So we gain flexibility. Okay. I'll just keep emphasize the same ideas. So if we focus on the short run and the long run, the idea is that in the short run, there is at least one factor of production whose quantity cannot be changed. Okay, at least one. So of course, for A2, we will keep things simple. We'll simply consider that there are 2 factors of production, capital and labor. So labor is going to be a variable, capital is going to be fixed. Okay, but generally speaking, you need to have at least one factor of production who is available in a fixed quantity. Okay, that's the idea. And in the long run, you can change the quantity of all resources, essentially, all factors of production that you use. You don't have anything like a resource available in a fixed quantity. You can use more or less of any resource that you use in your production process. Of course, the long run is more flexible than the short run, definitely. And yes, if we only focus on 2 factors of production, capital and labor, and this is what we do in A2, then both factors are variable. We can change the quantity of capital and labor. Okay, no problem. So, right. Please just remind the students that there is no way you can tell if the short run is 2 weeks, 2 months, 2 years. It depends. All right, it depends on the industries. There are some industries in which it's actually pretty quick to change the quantity of all of your resources. And there are other industries in which it's going to take much, much, much longer, perhaps because it is difficult to find qualified workers, maybe because it takes a long time to build the machines that you need to increase your production. So it really depends. So you should really avoid to tell them something like, yeah, the short run is less than 6 months, the long run is more than 6 months, because honestly, it really doesn't make any sense. It depends on the industry that you consider. Okay, good. So really start with this. You can have like this table in the student version. This table is empty, so they can actually fill it. If you want to remove the last row, So you can focus on the factors of production. And if you want to remove the first column and the last column, again, to focus on short run and long run, it's possible. This is actually a table that I used in AS because it is part of the first chapter. Okay, right. So it's always good to start with assumptions. So the assumptions are like the give us information about our framework. Okay, in what framework do we work? So again, the first assumption that matters is the idea that there are only two factors of production. In practice, this is clearly not true. Okay, we should add at least natural resources, or we could add enterprise, or but let's keep it simple: capital and labor. And of course, we will look at a business that only produces one good. In practice, again, when you think about it, it's not very realistic. Most businesses, they produce many different products, yes? But again, let's keep it simple. One firm produces one good. Okay. Then we are in the short run for now. Then we'll look at what happens in the long run. And we will assume that labor is the variable factor and capital is the fixed factor. Why do we make this assumption? Why not the opposite? Well, simply because in most industries, not always, but in most industries, it is indeed quicker or easier to adapt, to modify the quantity of workers that we have, to either employ additional employees or to lay off existing employees, rather than increasing the size of your factory or purchasing more machines. So that's why we consider that labor is more likely to be flexible in the short run. Okay, but again, this is just an assumption. And I'm sure you could find examples of industries in which it's likely to be would be the opposite. Okay, but that's a very common assumption in economics. Labor is flexible in the short run. Capital is not flexible in the short run. And something that is quite important to understand is that we will assume that all workers are the same. Okay, we sometimes say that they are homogeneous, which essentially means that they have the same productivity. Okay, you don't have something like a good worker, a bad worker, a worker with a high productivity, a worker with a low productivity. And it's very important to say that because I realized that some people, or in some books even, when we talk about the law of diminishing returns, and this is something we're going to talk, that I'm going to introduce pretty soon, sometimes I read that the reason for which they are diminishing returns is that essentially at first we hire all the good workers, and then if we want to produce more, all the good workers already have a job. So then we have to start employing bad workers and they are not very productive. Okay, and this would be why we have diminishing returns. No, that's not the reason for which we have diminishing returns. We'll see that this is about the combination of capital and labor. Okay, it's about the input mix, the combination of labor and capital. It's not about the quality of workers. Okay, and here all the workers are the same, exactly the same. And I like to use this example. I often tell them that workers are like stormtroopers. Yeah, you probably know these guys from Star Wars. And I like to use this example. Just give me a sec. So I have some people in the waiting room. Okay. I like to give this example because, well, most students know that, know who these guys are. And yes, if you have watched the Star Wars, if you have watched the movies, you know that these soldiers are actually clones, right? They have the same DNA. So they are exactly the same. So in theory, if they are exactly the same, if they have the exact same DNA, then they should have the exact same productivity, the exact same amount of human capital, for example. So yeah, I think that's a fun example of homogeneous labor, to have all workers that are absolutely identical. There is no such a thing as a good worker and a bad worker. All right, then we should start talking about product functions. In some books, in some textbooks, they don't really talk about product functions, and they start talking about cost curves right away. But to me, it doesn't really make sense, because if we really want to understand cost curves, we need to start with product curves. And this is also something that's going to be very useful when we talk about the labor market. When we talk about the labor market, we will need to introduce those product functions, those product curves. So I think now is the best time in the syllabus to introduce them. And what we can start with is the concept of production function, which is something very easy to understand. Just like any function, production function is just a relationship between two things. And here it's a technical relationship between inputs and outputs. Okay, so the inputs are like the resources, the factors of production, if you want, and the output is the product. Okay, what the company is producing. And yes, it's expressed in physical terms, so it could be a quantity of cars, or it could be a quantity of coal or lumber, things like that, of course. Okay. The first product curve that we must know is the total physical product. So here I have added this adjective, physical product, and not just total product. It's a bit tedious, right? It's a bit longer, but I feel like it's important to emphasize that, because again, later, when we study the labor market, we will have to distinguish between the physical product and the revenue product. Okay, so it's always important to make it very clear what we are talking about. The physical product is a quantity of output. Okay, and the total physical product is essentially the maximum output that you can produce with a given combination of inputs. Okay, so if I give you 10 workers and 5 machines, and if the company Seiko can, so it's a maximum potential output. Okay, just like a PPC, it doesn't really tell you what you actually produce. It tells you how much you could produce at best with this combination of resources. So if you can produce 100 watches with 10 workers and 5 machines, then your total physical product is equal to 100 watches. So you see that it is indeed expressed in physical terms. It is not expressed in monetary terms. It's not a dollar value. It's a physical value. Okay. Well, so far so good. Then you can start introducing the two additional product functions, the average physical product of labor and the marginal physical product of labor. Okay, so usually you can move rather quickly on this because it makes sense, and the students are already familiar with the concept of average something or marginal something. So it should go pretty quickly. The average product of labor is essentially the per unit output per worker. So you just divide your total product by L, a capital L, which is the number of workers that you have. Okay, that's the L for labor. That's pretty easy. Give examples. Make sure that you always give examples just to clarify. So if there is any doubt, the students always have an example that they can refer to double check, to make sure that they have clearly understand how this works. And graphically speaking, so you have the formula, and there is something that your students should know, because there are actually quite a few MCQs about that. It's about how you can actually measure or identify the average product on a diagram. So if you have a diagram that shows you the total product, the total physical product, okay, you have labor on the horizontal axis and the total product on the vertical axis, then your students must know how to identify the average physical product of labor. And the property that they must know is that it is simply equal to the slope of the line that is drawn from the origin to the total physical product curve. So let me just go through the example. So let's assume that this is, okay, the quantity of labor and the physical product, and this is my total physical product curve. Okay, so the more I produce, the more workers I hire, the greater my total physical product. Okay, and let's say that I currently have L1 workers. So this is my level of employment. And in this case, this gives me a certain level of total physical product of labor. Please be careful with something. Here we see quantity of labor. Does it mean that we only need labor to produce? No, that's not what it means. Of course, we need labor and we need capital, yes, but the quantity of capital is fixed. Okay, so that's why we cannot really make it change. It cannot be changed, and that's why here the only thing that can vary is the quantity of labor. But of course, the total physical product depends on the quantity of labor, but it also depends on the quantity of capital. Okay, it's quite important to keep this in mind. We need both factors of production to produce. All right, and if I give this quantity of labor, and if I ask, all right, so where is the average physical product of labor, then your students, they should know that it is equal to the angle of that line. Okay, so you draw a line that goes through the origin and that goes through this point on the total physical product curve, and the angle, or the tangent, if you want, of that line is equal to the average physical product. Why? Because this angle is simply the elevation divided by the run. Okay, so the elevation is your total product, and the run is the quantity of workers. Okay, so TPP divided by L1, this gives you the average physical product of labor. Okay, so they must know that, and it's actually true for any total average relationship. Okay, so this could be the total cost, the average cost. This could be the total revenue, the average revenue, blah, blah, blah. Anytime you have a total something, an average something, you always have the same graphical relationship. So this is something that is worth keeping in mind, quite important. Just a second. Again, some people coming late in the waiting room. All right. That's about it for the average physical product of labor. And for the marginal physical product of labor, we only look at the change in total output that result from the employment of the last worker. So sometimes, again, some books will tell you the resulting from the employment of the one additional worker. All right, it's fine. It's essentially the same thing. But I like to say the last worker. I think it avoids confusions when we use tables, for example. And I think it makes more sense to say last worker than additional worker. And you should not say the increase in total physical product, because yes, of course, in most cases, if you hire one more employee, well, it's going to allow you to produce more, but not necessarily. Okay, and we'll see later that it's actually possible that if you hire one more worker, your total output will actually decrease. So rather than saying the increase, it's more general to say the change. Okay, again, you have an example. I'm not going to comment it, but every time I give a definition like that, I give an example on how you can actually calculate it. And yes, same thing, your students, they should know how you can identify the marginal physical product graphically. Again, it's not useful for essay questions, but it's useful for MCQs. So again, if I have my total physical product, a given level of employment L1, then the marginal physical product of labor is just the tangent. Okay, it's the tangent. So I draw the tangent at that particular point, and the angle is equal to the marginal physical product of labor. And again, this is something that is always true anytime you have total something versus marginal something. Okay, the marginal is always the slope of the total. That's a sentence that I often repeat to my students. It's not extremely elegant, but it works, right? Could be true for total revenue, marginal revenue, total utility, marginal utility, total tax, marginal tax, blah. Anytime you have this total marginal relationship, the marginal measures the slope of the total. Why? Because the slope of the tangent is just the change in elevation divided by the change in the run. So delta TPP over delta L, this is exactly the definition of the marginal physical product of labor. Okay, so they must know that. Okay, it's not detailed. There are many MCQs that require this knowledge. All right, so for these three product curves, define them, give examples, and make sure your students know how to use diagrams that relate to that. Okay, and because the marginal measures the tangent, okay, the slope, that means that if you have a positive marginal physical product of labor, it means a positive slope. So your total physical product increases. Okay, positive slope means that the function of the curve increases. However, if you end up with a negative marginal physical product, then this would actually indicate that your total product would decrease. So here in this example, you see that it always increases, which suggests that the marginal physical product is always increasing. It was always positive, sorry, it's always increasing. And actually it's decreasing, we'll see that later, but it's always positive. Just like when we had monotonic preferences when looking at total utility versus marginal utility. Okay. Now we are ready to talk about something that is extremely, extremely important and for both MCQs and essay questions, and that sometimes creates some confusion amongst students because many of them, they confuse, they mix up the concept of returns to scale and diminishing returns. And yeah, in both terms, you have the word returns, so it can be a bit tricky. The law of diminishing returns is a short-run concept. Returns to scale, it's a long-run concept. Okay, so please repeat that 100 times to the students. And if I remember well, there was actually an essay question where students were asked to explain what is the difference between diminishing returns and returns to scale, or something like that, or economies of scale. Okay, so they must understand very clearly that one is a short-run concept and the other is a long-run concept. So what is this law about? So in general, if we look at a general framework, it just tells you that, all right, in the short run, if you increase the quantity of a variable factor without changing anything else, okay, so you don't change the quantity of all the other factor, then eventually, which means there will be a point beyond which the marginal physical product of that variable factor is going to fall. Okay, so maybe at first it's going to increase. Okay, why not? And that's usually the assumption we make, and I will explain that. But as we keep increasing the quantity of that variable factor, this law tells you that eventually there will be a point where this factor of production will become less and less productive. Okay, so yeah, it's a short run concept, definitely. And it has other names. In some MCQs, they actually refer to it as the law of variable proportion. Why variable proportion? Because let's say you only have capital and labor, but capital is fixed, right? So if you look at the ratio L over K, K is usually the letter we use for capital, okay? L is the quantity of labor, K is the quantity of capital. So of course, K is constant. So if you want to produce more, you should increase the number of workers that you hire, and therefore the ratio L over K is going to increase, okay? And if you hire less workers, the ratio L over K is going to decrease. So the proportion of capital and labor changes, okay? It's variable. So that's why we call that the law of variable proportions. And sometimes, and I actually like that better because it is a bit more explicit, we also sometimes call it the law of diminishing marginal product. We could even call it the law of diminishing marginal physical product if we want it to be even more clear. And because in our case, we keep things simple, there are only two factors of production, capital and labor. Labor is variable and capital is fixed. So that means that we increase the quantity of workers, the variable factor. Well, that means that eventually the marginal physical product of labor will decrease. Okay, that's the statement. That's the law. How do we understand it? Why is it the case? Well, that's actually quite simple to understand. it really is about the combination of capital and labor, what we sometimes call the input mix. Okay, an input mix is just a combination of resources. And the idea here is that if you have a given quantity of machines, or it could be office space, it could be trucks, it could be ovens in the restaurant, could be the side of the kitchen or anything like that, for a given quantity of capital equipment, well, there will be a point if you keep adding workers to that fixed quantity of capital, there will be a point where you will have too many workers for the quantity of capital available. We often use the sentence too many cooks in the kitchen just to express this idea, right? If you have too many cooks in the kitchen, well, there will be a point where they will be in each other's way, and this is something that is going to decrease their productivity, of course, right? So that's why there will be a certain point beyond which, if you have too many workers, where this fixed quantity of capital that you have becomes overused. Essentially, there is not enough capital for everyone. There is not enough capital for all workers. And the amount of capital that you give to your workers is something that directly influences their productivity. Okay, the more capital equipment you give to your workers, the more productive they can be. Okay, so if you just add more and more workers to the same, and if you keep the same quantity of capital, this essentially means that on average, each worker receives or has access to less and less capital equipment. Okay, could be machines, tools, equipment, office space. And of course, because they have less and less capital equipment, okay, on average, then this is something that is going to affect their productivity. So eventually, as you add more and more workers, labor productivity is, well, going to fall. That's it. And that's why the marginal physical product of labor will eventually fall. Yes. So that means that beyond that point, once diminishing returns start, as soon as you hire one more worker, then, okay, perhaps each additional worker is going to allow you to produce more, but the increase in total output will become smaller and smaller, which essentially means that each additional worker will be less and less productive. Okay. And what it means is that if we look at this, this is exactly what we see there. This means that your total physical product function, okay, it might remain increasing, but you see that it is increasing at a decreasing rate, which essentially means that as you add, let's say, one worker, two workers, three workers, four workers, you see that each additional worker allows total product to increase by a smaller and smaller amount. So when you have diminishing returns, then your total product is increasing, but at a decreasing rate. Why does it make sense? Because remember that the slope is the marginal product of labor. So if you have diminishing returns, the marginal physical product decreases, which means that the slope decreases. Is this the case here? Yes, the slope decreases. We have a concave curve. Okay, yes. And then I explain it. Okay, I think that's the best way to explain it. That's because the employment of each additional worker reduces the average quantity of capital available to each worker and therefore reduces labor productivity. I think it's a very clear-cut way of explaining this law. Okay, but and actually you can have a diminishing returns. So the MPP will decrease. It will decrease, 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 and it might even become negative. It's possible. In this case, we don't even talk about diminishing returns. We start talking about negative returns. And in this situation, this would, and this is what I explained before, this would actually mean that if you employ even more workers, instead of increasing production, working now? Can you guys hear me? Yes? All good? Okay. All right, thanks everyone. Yeah, I don't know what happens. This happened last week too with my mic. Sometimes it's just switched off. I haven't touched anything. So yeah, please type something in the chat box as soon as you can't hear me and I just unplug the mic and plug it again and then it works. Did you miss a lot? Maybe that's my AC my AC remote, right? That would be interesting. Maybe my AC remote actually turns my mic off. Who knows? That'd be interesting. Maybe interference, possibly. Did you guys miss a lot or just a few seconds? I hope my mic is not going to be switched off if I drink coffee. Let's see. 50 seconds. Okay, thank you. Yeah, all right. So how can you explain negative returns? You have more workers. How is this possible to produce less? Well, the idea here is that because we have more workers, each of them is getting less capital, okay, on average. And because capital equipment, the capital equipment you give to your workers directly influences and increases their productivity, this means that if you increase the number of workers that you have, but if you do not increase the number of capital equipment that you give them, that means that all your workers will become less productive. And if the decrease in productivity is significant enough, then overall, having more workers will actually lead to less production. That's the idea. Yes. So yes, even if the firm employs more workers, labor productivity has decreased so much that overall the total physical product decreases. Okay, and that's really the example of too many cooks in the kitchen. Of course, try to have 20 cooks in a small kitchen. I don't think they will be able to produce anything. Okay, that's the idea here. All right. And something that is quite important, because we do talk about diminishing returns, but in most diagrams, we actually assume that at first we have increasing returns. Remember when I defined the law of diminishing returns, I said that will eventually, right? The marginal product will eventually fall. But at first, what I mean at first is that at low levels of employment, yes, at low levels of employment, we often assume that the marginal physical product rises, okay, as you increase the number of workers. Why? Because let's pretend that you are that a business only hires one worker. Of course, this worker will have to complete many different tasks. It will not be possible to divide labor. It will not be possible to implement specialization. And therefore, this worker is likely to be rather unproductive. Labor productivity is likely to be quite low, simply because, yes, we cannot implement the division of labor. We cannot allow workers to specialize. So if you hire more workers, then it will become possible to assign different workers to different tasks, so they can gain skills, they can become expert at some tasks, and you know that, yes, the division of labor and specialization is something that does improve labor productivity. So that's why we believe that at first, increasing the number of workers that you hire can increase the marginal productivity of labor. We call that increasing returns. All right. And in this case, it's quite interesting. In this case, this means that instead of having a total physical product function that would be always increasing at a decreasing rate, this means that at first, it will actually be increasing at an increasing rate, okay? Because the slope is increasing, the marginal product is increasing, and then you would have what we call a turning point in mathematics, a turning point where your function would actually start to increase at a decreasing rate, okay? So you would have something like like that, okay? Where at first your total product increases at an increasing rate, okay? So the marginal product increases, increasing returns. Then you have your turning point at L1, where it starts to increase, but at a decreasing rate. So the law of diminishing returns essentially starts here, if you want. And then your total product might actually start to decrease if your marginal product becomes negative. We call that negative returns, okay? And this is what you would have if you graph the marginal product. So at first it increases, it reaches a maximum just before diminishing returns set in. And then you see it falls, it falls, it falls, it falls, it falls. And it's possible, not necessarily the case, but it's possible that it even becomes negative. And if it becomes negative, then we have negative returns, okay? So you see, the law of diminishing returns does not start from the first workup. That's what I meant by will eventually fall, okay? Marginal product will eventually fall. That's what I meant, okay. Right, I told you at the beginning of today's workshop that I was not completely done upgrading the resources, because of course you know that you can already download the PPTs from the EconDoctor website, but I want to improve them. Well, every year I try to improve the documents, and I want to add an example, a fun example for your students to practice and to understand how this works. So this is something that I'm going to do later this week. So you should wait a little bit before downloading the PPTs, because I will add this example. So please come back to the website Thursday or Friday so you can download the updated version of the PPT with this concluding example about the law of diminishing returns. All right. Any questions at that stage? Are we good? Should we move on? Should I take this as a yes? All right, now we have introduced these product functions. And your students, they must know the relationship between them, especially the relationship between the average product and the marginal product. And the rule is quite simple. If the marginal product is greater than the average product, then the average product goes up. Okay, that's how you can summarize it. And if the marginal product is smaller than the average product, then the average product goes down. Okay, same thing, boom, boom, boom. And if both are equal, then the average product is constant. Okay. How can we make sense out of it? So it's actually very easy to understand with examples. So I have designed 2 examples, and then I will show you the conclusion. All right, with 2 examples to understand why this is the case. So the first one is about a PE teacher who asks students to do push-ups, as many push-ups as possible in 10 seconds. So let's say there are 20 students. Overall, they make 160 push-ups in 10 seconds. So on average, each of them did 8 push-ups, okay? 160 divided by 20. That's our average product, the total output divided by the number of students. And then let's say that there is a late student, a 21st student who shows up. So the coach says, all right, you have to do as many push-ups as you can in 10 seconds. So that's like the additional student. So that's like the marginal product, if you want. And of course, we understand that if this 21st student does more than 8 push-ups, then this student is going to take the average up. Okay, the marginal is greater than the average, so the average goes up. Okay. On the contrary, if the student does less than 8 push-ups, then the average is going to go down. Okay, so when the marginal is less than the average goes down. And if that student does exactly 8 push-ups, then of course, so the marginal is equal to the average does not change. That's super easy, right? To use to understand this way. And I have another example with grades. Okay, so we have Michelle, a high school student, and she has received a 6th grade. Okay, so I can calculate the average. The average is 14, and let's just assume that she receives an additional grade that we can, well, that we should interpret as the marginal grade. And of course, if this additional grade is above 14, then the average goes up. If it is less than 14, the average goes down. And if it's exactly 14, the average doesn't change. Okay, so that's exactly why we have this relationship between the marginal product and the average product. So if you just use these two examples, that should be quite easy for your students to understand how this works. Right, what does it mean? If we try to understand in terms of consequences, it means that as soon as it essentially means, okay, that the marginal product curve will cut the average product in its maximum. Let me show you on the diagram. Okay, of course, you see, as long as the marginal is above the average between 0 and L1, then the average increases. But as soon as the marginal becomes lower than the average goes down. Okay, so essentially, as soon as the marginal product curve cuts the average product curve, this means that the average product will start decreasing. So the marginal cuts the average in its maximum in this case. Okay, that's very important. Why? Because let me just do a little trick. Because if I flip this, let me just I don't know if you guys can still see it. Let's just group it. If I flip it, oh, what do we get? See, marginal cost, average cost. Okay, so I feel like it's important to start with product curves, so then we can better understand cost curves. Okay, and we are done with product functions. So now we can talk about short run cost functions or cost curves. If you don't like functions, you can replace by curves. That works too. Okay, first thing that we got to say is that because we are in the short run, because there is a fixed factor of production and a variable factor of production, then there will be a fixed cost and a variable cost. Okay, so what is the fixed cost and what is the variable cost? Let's start with some definitions. So a fixed cost is one that does not change with output. Okay, so it doesn't matter how much you produce, the fixed cost doesn't change. That's why it's fixed. And a variable cost is a cost that changes with output, and of course it increases. Why? Because if you want to produce more, you need more labor, and therefore your variable cost will increase. So that it's more precise to say will increase rather than just change. Yes. And because here in our framework, we are in the short run and the fixed factor is capital, then the total fixed cost is the cost of capital. Okay. And because in our framework, the variable factor is labor, then the total variable cost is just the cost of labor, the cost of hiring the employees. Okay. And the total fixed cost is the cost of purchasing the machines and everything. Yes. And what we call the total cost is just the sum of the total fixed cost and the total variable cost. Okay, pretty simple, pretty straightforward. This is how you can graph it. So if you now be careful, because when we looked at product curves, we actually had labor, right? We had the quantity of input on the horizontal axis. But now when we look at cost curves, we have the quantity of output on the horizontal axis, okay, and the cost on the vertical axis. So the total fixed cost, by definition, it doesn't change with output, so it's represented by a horizontal line. It's constant. However, the variable cost increases with output. So in fact, it doesn't really matter. The shape doesn't really matter. Okay, so here I represented it like that. But if you want to represent it as a straight line, it's fine too. If you want to represent it as just an exponential curve, it's fine too. So this would actually show constant marginal product of labor. Okay, so in that case, the law of diminishing returns would not apply. So that's why I did not represent it as a straight line. And if you had like just an exponential curve, so it's always increasing at an increasing rate, it would actually mean that we have diminishing returns from the start, okay, from the first unit of output. On the other hand, if you have this curve, you see first it increases at a decreasing rate, and then there is a turning point, and it eventually increases at an increasing rate. This means that first we have increasing returns, and then we have diminishing returns. So this is the more realistic representation, okay? But what matters here is that the variable cost increases, okay? And if I add these two, I get the total cost, okay? So the total cost is just an upward shift of the variable cost and the vertical distance between the two, okay? I can take any given level of output, and the vertical distance between the total variable cost and the total cost is just the fixed cost, the total fixed cost. Okay, pretty easy, no problem. Then we are ready to talk about the average total cost. That should not be too complicated. It's just the total cost divided by the quantity. Use an example. Use an example to make sure that your students know how to calculate an average total cost. No problem. Again, please emphasize the graphical properties. Remember, the average always measures the slope of the line that goes from the origin to the curve. Okay, so essentially, I think I have, yes, that's the total. If I look at the quantity of output, Q1, this is my total cost, TC1. So I look at that point on the total cost curve. If I draw a line from the origin to that point, I look at the slope of that line. That's my average total cost at that level of output, okay? Because this is the elevation, TC1 divided by the run, Q1. That's my average total cost. Okay, no problem. Then you are ready to introduce the marginal cost. Should be pretty easy. Same thing. This is not necessarily, well, actually you could say the increase, because I do not really see how you could produce more at a lower cost unless people pay to work, but I don't think that's going to happen. So yes, you could actually say that's the increase in total cost generated by the production of the last unit of output. Oops, sorry, what did I do? You see, mistake here. That's not the formula. Okay, that's better. Sorry, small mistake. And I noticed something was wrong here. Okay, better. All right, so the marginal cost, blah, blah, blah. Give an example, same thing. And again, give the, explain that yes, the marginal cost represent the slope of the total cost curve at any given level of output. So you take Q1, you have one point on that curve, you draw the tangent, and the slope of that tangent is your marginal cost. And actually, I don't really want to give you too much explanations about that, but this is, it also measures the slope of the variable cost function, right? Because they have the same slope. If you look at these two curves, okay, variable cost and total cost, at each point, at each level of output, they have exactly the same slope, okay? So the marginal cost measures the slope of the total variable cost and also the total cost. Okay. Okay, all good. And finally, you can give the formula of the average fixed cost, the average variable cost, and the average total cost using these and the relationship with the average fixed cost and average variable cost. You can usually move pretty quickly with this because it is quite straightforward, and the kids, they usually understand that pretty well. But of course, you should not move on before you practice with them, just to make sure that they have understood how this works. I have actually, I don't know if maybe some of you used my PPTs last year and you are maybe familiar with that table, but I have decided to simplify it because I actually used the table where the quantity of output went from 0 to 10. Some numbers were a bit tedious to calculate, so I tried to come up with something easier. So I change the table, I make it easier. And essentially, it's a game. It's like a Sudoku, right? Where, well, not exactly a Sudoku, but you just have some information. You simply have the minimum information that you need to fill in the table. So yeah, you can practice just to make sure that you find the right steps. But with this information there, you are able to fill that table, and you see the numbers tend to be easier than from the table that was in my PPT last year. So that should be more convenient for your students to yeah, to just practice. So that's great because it really forces them to remember the definition of each, the formula to go from one to the other. So I really like this exercise, a great way to make sure that they are familiar with all these cost curves. Okay. And then as a, not really a conclusion, but because we've talked about product curves and we've talked about cost curves, so it's interesting to analyze the relationship between the two curves. And you can actually take, let's say, a curve 2 by 2. You can look at the marginal product curve and the marginal cost curve. And there is something that the students must know, is that they have opposite variations, which means that when one rises, the other decreases, okay? So for example, if you have a higher marginal product, then the marginal cost falls and vice versa, okay? So if the marginal product falls, the marginal cost rises. It's quite easy to understand why it is the case. You don't need to prove it. It's very intuitive. If you have a high, or let's start with a low. If you have a low marginal product, it means that the last worker that you can hire is essentially pretty bad, not very productive. So if you want to produce more, you need to hire many extra workers, because each additional worker is not going to be very productive. And because you need many extra workers to produce one more unit of output, well, this means that it's going to be very costly for you to produce this additional unit of output. So your marginal cost of production is going to be quite high. On the contrary, if your last worker is very productive, so high marginal product of labor, it means that you do not need to hire many extra workers to produce one more unit of output, okay? Because every additional worker you hire is very productive. And because of that, it's going to be quite cheap to produce one more unit of output. So your marginal cost is pretty low. That's it. Pretty easy to understand. And we have the same opposite relationship between the average product of labor and the average product of the average variable cost. If one rises, the other goes down. Okay, same thing. How do we explain it? Well, of course, if your workers are not productive on average, okay, on average, it means that on average, you will need a lot of workers to produce each unit of output, okay? And therefore, on average, it's going to be costly to produce each unit of output. So your average variable cost, remember that the variable cost measures the cost of labor, okay? So it's going to be pretty high. But again, if on average your workers are very productive, this means that you do not need many of them to produce each unit of output, and therefore your average variable cost is going to be quite low. All right, so it's pretty easy to understand why these product and cost curves have opposite variations. And you can actually, I like this diagram very much. It's like a mirror. When one goes up, the other goes down, blah, blah, blah. So you see that indeed, if we start comparing the marginal product and the marginal cost, we see clearly that when one goes up, the other goes down. And when one goes down, the other goes up, okay? And same thing for the relationship between the average product and the average variable cost. When the average product goes up, the average variable cost goes down. When the average product goes down, the average variable cost goes up. And the consequence is that, remember, we said that the marginal product cuts the average product in its maximum. And because of this mirror image, we can convince ourselves pretty easily that this means that the marginal cost will cut the average variable cost in its minimum, okay? Which again is very intuitive, okay? If producing the last unit costs less than the average cost of production, then it's going to take the average down. But if producing the last unit is more costly than the average cost of production, then it is going to take the average variable cost up. Easy to understand. Okay. How do we graph all these cost curves? Because there are quite many. There is the average fixed cost, there is the average variable cost, there is the marginal cost, the average total cost. And it's quite important for your students to be able to draw this diagram properly. So let's just look at this diagram and let's just make sure that we do everything right, okay? So let's start with the easiest thing. The average fixed cost goes down always, just like the function 1 over x. It just gets closer and closer to 0. It is never negative. It's always positive, but it becomes smaller and smaller. We call that the spreading effect, okay? Because you spread, as you increase output, you spread your fixed cost, your total fixed cost, on more and more units of output. That makes your average fixed cost smaller and smaller. So it tends towards 0. Now, the average variable cost as well as the average total cost, they are usually assumed to be U-shaped, okay? Because we often assume that at first they are increasing returns, okay? And we see it because the marginal cost first goes down, okay? When the marginal cost goes down, this means that we have increasing returns, and that's why the average variable cost and the average total cost, they start sloping downwards. But then eventually they will start rising, and I'm going to explain that in a minute. Okay. Of course, the average total cost is above the average variable cost, but you should make sure that they become closer and closer. You see, we can see that on the diagram. At first, at the low level of output, the vertical distance is relatively large, but then as I increase the quantity of output, the vertical distance becomes smaller and smaller. Why? Simply because the vertical distance is equal to the average fixed cost, and the average fixed cost decreases. Okay, so that makes sense. It's more precise to make these two curves become closer and closer. You should make sure that the marginal cost goes through the minimum of both your average variable cost and the average total cost. Okay, you see that on this diagram, which means that the average variable cost reaches its minimum at a lower level of output than the average total cost. Okay, the average variable cost is minimized at this level of output, and the average total cost is minimized at this level of output. And this level of output, we call it the minimum cost output, MCO, minimum cost output. In the long run, we call that the minimum efficient scale, yes, but in the short run, the minimum cost output. And I think that's about it. Okay, so yeah, it's a very important diagram, so make sure that your students get it right. So summary, yes, the MC curve cuts the average total cost and the average variable cost in their minimum. The average fixed cost curve is decreasing, the spreading effect. The vertical distance between ATC and AVC narrows as we increase output. The ATC curve reaches its minimum at a larger output than the AVC curve. We saw that. And the level of output at which the ATC is minimum, we call that the minimum cost output. So of course, if you want a business to achieve productive efficiency in the short run, remember that the condition is to produce at the minimum possible average total cost, And of course, one condition, one necessary condition is for that firm to operate at the minimum cost output. To operate means to produce. Okay, so the firms must produce the minimum cost output. Yeah. Okay, and that's about it. Last thing, and we will be done with production in the short run, is to explain why the ATC curve is U-shaped. Okay, all right. See, you have, and I usually explain it with 4 stages, and I try to explain what happens in each stage. Okay, let me just plug my computer because I am out of battery. Again. Oh, here we go. All right. So if we want to understand why the ATC curve is U-shaped, and again, that's more like an assumption, but it does make some sense. So let's try to explain it. We have to remember first that, of course, the ATC is just a combination of the AFC and the AVC. Okay, so of course, the changes in the average total cost are entirely determined by the changes in those 2 average cost curves. The average fixed cost, it's easy because it always goes down. Yes, that's what we call the spreading effect. So according to this spreading effect, basically it is an effect that is going to contribute to reduce the average total cost. Okay, but the average variable cost is usually assumed to have a U-shape. Why? And to keep it simple, that's because of this assumption that I have already discussed earlier. That's because we believe that at first there are increasing returns, because if you have more workers, they can become more productive because of specialization, because of the division of labor. So at first, we believe that workers become more productive on average. So the average variable cost goes down, okay? Greater productivity, lower cost of production, that's the idea. But according to the law of diminishing returns, eventually workers will become less productive. Okay, the marginal physical product of labor will fall because there are just too many workers and not enough capital equipment. And therefore, the average variable cost is eventually going to increase. Okay, that's what we sometimes call the diminishing returns effect. So you have 2 effects: a spreading effect that takes the average total cost down, and the diminishing returns effect that takes the average total cost up. All right, and you see in my diagram, I have identified 4 stages. So what do we see in stage 1? So of course, the AFC goes down, that's the spreading effect, and the marginal cost also goes down, which means that we have increasing returns. Yes. And in that case, the marginal cost is below the average variable cost. So the average variable cost goes down, okay, because of increasing returns. Yes, so AFC goes down, AVC goes down. So of course, ATC goes down because just the combination of the 2. Then stage 2 is actually quite interesting, because we see that the marginal cost has already started to increase, which means that we already have diminishing returns. Okay, diminishing marginal returns. Remember, let me go back a bit. Remember this diagram? Okay, if you have, as soon as the marginal cost increases, that means that the marginal product has already started to decrease. All right, so we already have diminishing returns. However, the marginal cost remains below the average variable cost. And remember, when the marginal is below the average keeps going down. And so again, we still have the spreading effect that takes the ATC down, and we still have an average variable cost that goes down. So basically, even if workers become less productive, they are still pretty productive. So that still takes the average variable cost down. Stage 3 is interesting because now we see that the average variable cost starts to increase. Why? Because the marginal cost has now become bigger or greater than the average variable cost. Okay, so like basically here we really start experiencing this diminishing returns effect. It really becomes more complicated to produce more expensive to produce more, because our workers are really less productive. So here you actually have two different effects that work against each other. On the one hand, you have your spreading effect that keeps taking the ATC down, but you now have this diminishing returns effect that takes the ATC up, that contributes to increase the ATC. But what do we see? We see that overall, if I add these two effects, I still see that my ATC, keeps decreasing. Okay, we are still on the downward sloping section of the ATC, which indicates that which effect is the strongest between the spreading effect and the diminishing returns effect. Well, in that case, the spreading effect is the strongest. And finally, stage 4, well, eventually the ATC curve starts to rise. So we still have the spreading effect, but you see that the AFC curve becomes flatter and flatter, which essentially means that, yes, the spreading effect is not very strong anymore. Okay, the flatter this curve, the weaker the spreading effect. And on the other hand, you see that your marginal cost increases more and more. The diminishing returns effect becomes stronger and stronger. The AFC curve increases, the AVC curve increases at a faster and faster rate. So eventually during this stage 4, the diminishing returns effect is much stronger than the spreading effect. And that's why overall the ATC rises. So if we combine all this, we understand why the ATC curve eventually has, or overall has, a U shape. So that's how you can make sense out of it. So I'm not going to go through that, but essentially you see I explain the different stages, okay? What they mean, how we can interpret these different stages. And finally, one short exercise for your students to make sure that they have understood. So you have one diagram, where I've given some letters to different points, and students have to use this diagram to calculate these different costs: average total cost, AVC, AFC, and total cost. And that's it. We are done with production in the short run. So as I said, my apologies, no summary yet, no list of definitions yet, but this is all going to be available in a couple of days. Please wait a little bit before downloading and printing the PPT. I still want to add one example to illustrate the law of diminishing returns, like some kind of an example that would summarize the key ideas. Yeah, I really want to keep my to maintain the highest possible quality for my PPTs, and unfortunately it takes time, but don't worry. Later this week you will have all these documents. I don't think you have started teaching that to your kids anyway, right? Or if you have, you are very fast. Okay, questions before we talk about production in the long run? Do you guys have any questions? Or should we move on? Could be questions, could be remarks, could be feedback, anything. All good? Okay. All right, so same thing, production in the long run. I still want to improve the PPT a little bit. It's not going to change much. I might just simplify a few things, but yeah, essentially that's it. Just want to modify a few things. Okay, let's start with some assumptions. So now the key difference is that we still have two factors of production. We still have a business producing a single product, but here we now have, we are in the long run, so we can change the quantity of capital and labor, both factors, both types of resources. We still have resources that are homogeneous. So again, all workers have the same productivity. They are like stormtroopers, exactly the same. All machines have the same quality, right? You don't have anything like a good machine and a bad machine. Okay, they have the same productivity. Okay, and I like to start with this. I like to start by reminding kids that, yes, remember when we studied consumer theory, we said that sometimes you have two goods or two services that can either be substitutes or complements in consumption. Two goods that basically one can replace the other, or two goods that are better if you can consume them together. And actually, it's the same thing with resources. It's the same thing with the factors of production. Sometimes you have resources that uh, are substitutes, especially sometimes you can replace capital by labor or labor by capital. Okay. So for example, you can replace cashiers by automated ordering system. If you go to many stores like Decathlon or BLT or maybe Bravo, you can do some self checkout, or you can actually have a cashier assisting you. So that's an example where you have two factors of production, capital and labor, that are actually substitutes. Could be an ATM and a bank teller if you want to withdraw cash. There could be workers and assembly lines. All right, sometimes, yes, you can replace capital by labor and vice versa. In that case, it essentially means that your resources are substitutes. Or, but we are not going to talk about that, but it might be interesting to realize that sometimes resources are complements. You need to have them together if you want to produce anything. If you hire a carpenter, someone who builds roofs, but if you do not give like the relevant or the necessary capital equipment to your worker, nothing is going to happen. If you buy trucks, but if you do not hire drivers, same thing, you're not going to produce anything. If you hire doctors, but if you do not give them X-ray machines, same thing, you're not going to produce much, right? But in this topic, it's important to understand that we will make the assumption that capital and labor are actually substitutes. Okay, so you can replace one by the other, which means that you have several ways you can produce the same level of output, something that was not the case in the short run. In the short run, there was only one way to produce every given level of output. So you did not have to make a decision on how to produce. If you wanted to produce, let's say, 100 cars, because the quantity of capital was fixed, the only thing that you had to find out, not really even to decide, but to find out was, okay, how many workers do I need to produce 100 cars, given that I have a certain quantity of machines? So you did not have to choose the input mix. Remember, the input mix is the combination of resources. You did not have to choose whether you wanted to have more capital and less labor, or more labor and less capital. You were essentially stuck in the short run. But now in the long run, that's really very, very important to understand that. That's the key idea. There are several possible combinations of inputs for the same level of output. You could say that there are several production processes whose capital intensity differs. The capital intensity is just the ratio between the number of, or the quantity of capital and the quantity of labor. So we say that the production process is capital intensive if you have relatively more machines than workers. And we would say that the production process is labor intensive if you have relatively more workers than machines. Okay, so that really is the key idea. And now, because we are in the long run, we have to choose. How do we want to produce? Do we want to produce with many workers and few machines, or with many machines and few workers? We have to choose the best possible combination of resources. So what do we mean by best combination? We mean the one that will allow you to produce at the lowest possible cost. And that's why this slide is called cost minimization. We have to find the best input mix. Okay, so yeah, the producer must choose the combination of inputs that minimizes the total cost of production. Okay, and then you have a lot of slides. You have a lot of slides with the one step further arrow, star, sorry, not arrow, the one step further star. And this is really beyond the syllabus. So please, please, please do not do that with your students. I have prepared all those slides because I really like production theory. This is something that I used to teach at the university, and I really enjoy it. So I could not resist, and I really wanted to talk about ISO cost lines, to talk about isoquants, which are like indifference curves for producers, and to explain, yes, the difference between a short-run production function and a long-run production function. How beautiful, like a three-dimensional diagrams. Yes, it took me a long time to prepare. And just like indifference curves, I wanted to talk about the properties of isoquants, the marginal rate of technical substitution, which is the equivalent of the MRS, but for producers, but it works essentially the same. And then I really wanted to explain how we can actually solve the problem of the business, and to emphasize that it eventually works just like in consumer theory. You know, we must be there must be some kind of a tangency point between the isoquants and the iso cost lines. All right, all this is very beautiful. All this is very interesting. So if you are curious about all this, or if you have very eager students who might be interested in just going the extra mile and learning a bit more about that, then you might just print the PPTs for them. But this is definitely not going to be useful for the exam. And in my case, I just don't do it. I don't even mention it. Okay. Well, again, I couldn't really resist. So yeah, I usually start here. So what is the slide number? Yeah, so you see, I skip 120 slides. All right. But just please emphasize the beginning. It's very important that you explain to them that, yes, the major difference between the short run and the long run is essentially that now firms have the choice. They can choose how to produce a given level of output. All right. And I usually start then with the concept of long run average total cost. What is the definition? It just gives us the lowest possible ATC for any given level of output when all the factors of production are variables, of course, because we are in the long run. Okay. What do we mean by lowest possible ATC? Well, this would mean that this is the lowest possible, we would achieve the lowest possible average total cost, essentially, if we have chosen the best combination of capital and labor. If we have not used the best possible combination, the best possible input mix, then it means that we do not produce this given level of output at the minimum possible cost, and therefore our average cost would be higher than what it can be. But if we have implemented, or if we use the best combination, the most efficient, the most cost efficient input mix, then we would be on the long run average total cost curve, not above it. So again, I'll just read that because there's a lot of information and sometimes it takes a bit of time to wrap your head around this. So what does it mean to rephrase it? This means that the long run average total cost curve shows a relationship between output, of course, and the average total cost when we have chosen the best possible combination of input. That's about it. And this long run average total cost curve is usually, again, assumed to be U-shaped, again, essentially for the same reasons as before, but then we'll talk about the concept of economies and diseconomies of scale. So for now, just tell your students, we usually believe that long run average total cost curves are U-shaped. We'll see that later. And the level of output at which it is minimum, we don't call that the minimum cost output, but we often call that the minimum efficient scale. Yes. All right. And of course, just like before, if you want the firm to be productively efficient in the long run, then again, it is necessary that this business is producing at the minimum efficient scale, or this firm must operate at the minimum efficient scale. It is a necessary condition. All right. Let's just start with the diagrams, and then I will go back a bit. So this is my long run average total cost curve, okay? And this is one short run average total cost curve. There are actually many short run average total cost curve, and you see that there is an index KO, because each ATC curve in the short run is associated with one quantity of capital. Okay, because remember, the quantity of capital is fixed in the short run. Okay, you take it as given, but you can either have, let's say, a small fixed quantity of capital, an average fixed quantity of capital, or a large fixed quantity of capital. Okay, there are several possibilities. Essentially, the quantity of capital that is fixed in the short run is a parameter. It could have a low value, it could have a high value. Okay, and each quantity of capital that you have in the short run will be associated with one short run ATC curve. So here, what do we have? You see that this short run ATC curve is always above the long run ATC curve, apart from this point. Okay, so let's try to understand why this is the case. At this point, at Q1, if we produce Q1, what do we see? We see that the cost in the short run over there is greater than the cost in the long run. What it means is simply that for this level of output, K0, this quantity of capital is not optimal. Okay. Having K0 units of capital is not the best combination, or is not the best quantity of capital to produce this quantity of output. Same thing, if I look at this quantity of output, I have the same I have the same outcome, right? the cost in the short run is greater than the cost in the long run. Again, how can I interpret this? Simply by saying that, okay, it means that this quantity of capital, K0, is not the optimal quantity of capital to produce Q2, units of output. Okay. And finally, at Q3, I see that indeed, in that case, the cost in the short run is the same as the cost in the long run. How do I interpret this? Simply by saying that, yes, K0 is the best possible quantity of capital to produce Q3 units. So what does it tell us about the other quantities? It simply tells us that, all right, if K0 is the efficient quantity of capital to produce Q3, this means that K0 is too large. This quantity of capital K0 is too much to produce Q1, but not enough to produce Q2. Okay, so that essentially means that at Q1, because the quantity of capital K0 is too much, this means that capital is underutilized. We have too much capital and not enough labor. So that's why this is not the best possible input combination or input mix. And because we have not used the best input mix, the cost in the short run is higher than the cost in the long run. And in this case, it's the opposite. Here, the quantity of capital that we have is insufficient, which means that the quantity of capital that we have in the short run is overused, overutilized. We do not have enough capital. We have too many workers for the fixed quantity of capital. All right. So again, the consequence is the same. This means that we do not have the right proportion. When I say combination, I actually mean the proportion between capital and labor. We do not have the right proportion, and therefore this means that we do not produce at the lowest possible cost, and that's why the cost in the short run is above the cost in the long run. Okay, so that's how you can explain, that's how you can understand this relationship between the short run ATC and the long run ATC curve. All right. And as I said, of course, here I only represented one short run ATC curve associated with one possible level of capital. But again, there are several possibilities. You could look at what your ATC curve would look like in the short run for different quantities of capital, okay, K1, K2, K3. So for example, K1 would be, what if I only had one machine in the short run? SRATC2 would be, hey, what if we had two machines? And SRATC K3 would be, oh, what if we had three machines? Okay, and in all cases, you see that we always have this relationship where each short run average total cost curve is such that it is always above the long run ATC curve, but there is always one point of tangency, which would mean that the quantity of capital K1 would be suitable in the short run if we want to produce K1 units of output, okay, would be too much if we want to produce less than Q1, and it would be insufficient if we want to produce more than Q1. The quantity of capital K2 is efficient if we want to produce Q2, okay, that's how we see it. It would be too much if we want to produce less than Q2, and it would be insufficient if you want to produce more than Q2. And finally, the fixed quantity of capital Q3 would be suitable, would be efficient to produce Q3 units of output. It would be too much to produce less than Q3 and insufficient to produce more than Q3 units. All right, there's a question in the chat box. Let me have a look at it. Could you please repeat there why on most occasions at different quantities SR-ATC is higher than LR-ATC? Why isn't it possible that maybe LR-ATC is higher than SR-ATC, or what is the crucial factor that determines that LR-ATC is always lower than LR-ATC? Okay, good question. So remember, when we are in the long run, we can choose the quantity of capital and we can choose the quantity of labor. Okay, we have freedom, if you want. We can combine these factors of production in any proportion we want. So essentially, you can see that as a two-step process. First, the business has to choose how much to produce. Okay, so it could be, all right, I want to maximize profit, MC is equal to MR, boom, that gives me the quantity that I should produce to maximize my profit. Okay, then once I know how much I should produce, say to maximize my profit, I have to decide how to produce, because I am in the long run, so I actually have the choice. I can produce, let's say, Q3 units with many machines and a few workers, or the opposite. And because we are in the long run, that means that for any given level of output, the firm will always have the ability to choose the best combination. Okay, because we can choose in the long run. We can choose to combine capital and labor any way we want. And because in the long run, I can always choose the best combination, I will always produce at the lowest possible cost. But this is not true in the short run, because in the short run, we are stuck. We cannot combine capital and labor any way we want, because capital is fixed. So once I have a fixed quantity of capital, let's say, okay, 10 machines, let's just give a simple example. Let's say that the best way to combine capital and labor is one machine for one worker. Okay, let's just simplify. That's the best way to combine your resources. This is the way that would allow you to produce at the lowest possible cost. Okay. So let's say you have 10 machines and you want to produce 100 units. Okay. So you think about it. All right, if I want to produce 100 units, I need 10 workers. I need to combine 10 workers with the 10 machines that I have. Okay, in that case, it's great. You have 10 machines, you have 10 workers. So that means that you are lucky, essentially. You can combine capital and labor in the optimal proportion. Okay, but what if, for some reason, you want to produce more? Instead of producing 100 cars, you want to produce 120. Can you do it in the short run? Can you produce more? Yes. But the only way you can produce more in the short run is by hiring more workers. You can't buy more machines. So that means that, let's say you will still have your 10 machines, but now you will have 15 workers. So, okay, it does allow you to produce more, 120 cars, but you see that now you do not combine capital and labor in the best possible way, which means that you do not produce these 120 cars at the lowest possible cost. So this would be, for example, there. So example Q3 would be 100 cars, and this would be 120 cars. Your cost of production in the short run is not as low as it could be, because you would actually need more machines and more workers if you wanted to produce 120 cars at the lowest possible cost. So essentially, to summarize, in the long run, we always produce at the lowest possible cost, simply because we have the possibility to choose the best combination of capital and labor. But in the short run, because the only way we can adapt our level of production is to modify the quantity of workers that we hire, it is possible, and it's actually likely, that the quantity of capital that we have will not be suitable to the level of production that we want. If we have not enough capital equipment, then problem, we have too many workers, bad combination, and therefore we don't minimize the cost of production. So my cost in the short run is more than my cost in the long run. And if for some reason we have too much capital in the short run, same thing, we don't have enough workers relatively to the amount of capital that we have, bad combination. And again, that means that my cost in the short run is more than my cost in the long run. Does it make sense? Yes? That's the idea. Long run is always optimal because we can choose whatever combination we want. The short run, we might be stuck. That's it. But there is an example that I call Ben's Car Factory that explains it pretty precisely. Okay, other question. We do not consider the payment to labor capital and discuss short-term, long-run issue. Why I ask this question is that I do not fully understand, since they are perfect substitute. They are not perfect substitutes, actually. They are imperfect substitutes. Otherwise, if they were perfect substitutes, you would end up with only one. You would produce only with capital or only with labor. Just like the law of diminishing marginal utility, you have the law of diminishing marginal physical product, or the law of diminishing returns, which implies that the substitutes are not perfect substitutes, essentially, because of the law of diminishing returns. Because yeah, otherwise you would, if they were perfect substitutes, you would only use the factor of production that has the lowest price. So no, there is, you have the possibility to replace one by the other, but they are not perfect substitutes. Okay. All right, so here, okay, you have another example where you have 4 short-run ATC curve, and remember, each of them is associated with a fixed quantity of capital in the short run, and of course each quantity of capital is suitable, efficient at producing only one level of output. So Q1 is optimal for K1, Q2 optimal for K2, blah 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 blah. But for any other level of output, you see that that's not going to work very well. Okay, this is how you can actually show how to build the long run average total cost from your short run ATC curve. And I actually like this better than this. I don't really like this diagram. It's a bit unclear. I really like this representation better. So let's just assume that in the short run, there are only 3 possible choices of capital. Okay, you can either have 1 machine, 2 machines, or 3 machines. Okay, it's a fixed quantity. Could be 1, 2, or 3 machines. Of course, each solution will be associated with one short-run ATC curve. Okay, so SR-ATC1 is your short-run ATC curve when you have 1 machine, blah blah blah. Okay, and then what you can do in the long run is essentially you can choose where you want to be. You can choose what's the best. So for example, if you are in the long run and you want to produce Q1, Q1 is the quantity that maximizes your profit. So then you basically have to choose how many machines should I use? Because you are in the long run, you can choose. Do I want 1 machine? Okay, so we would be there. Okay, this would be our cost of production in the short run if we choose 1 machine. Do I want 2 machines? You see, it's higher. Okay, if you have 2 machines, then in the short run, this would be your cost of production. Or 3 machines, I have not even represented it because it would be very high, right? We need to take this curve and to continue it very, very, very high, and this would be your short-run ATC cost if you produce Q1 with 3 machines. All right, of course, the best option that you have, the best combination, if you want, is to use just 1 machine in the short run. Same thing, you can just say, all right, what if I want to produce Q2? Should I get 1 machine, 2 machines, or 3 machines? With 2 machines, this would be your cost of production. 1 machine, this would be this cost of production. And 3 machines, same thing, it's much higher. Okay, I would continue there. And I can also do it for, let's say, this level of output. Now, what if I want to produce Q3 units of output? Or same thing, you can ask yourself, what is the best solution that I should choose? Should I get 1 machine, 2 machines, or 3 machines? And you see here that the best decision that you can make is to get 3 machines, because this is what would allow you to produce this level of output Q3 at the lowest possible average total cost. Okay. So then eventually you can do that for any given level of output, and you see that for any given level of output from 0 to this quantity over here, the best, let's say, quantity of capital is 1 machine. This is what will allow you to produce at the lowest possible ATC. For any quantity of output between this level and this one, you see that the best quantity of capital that you should use is 2 machines. Okay. And finally, for any level of output that is greater than this quantity there, the best quantity of capital equipment, the one that would allow you to produce at the lowest cost, is 3 machines. So overall, boom, this is your long run ATC curve. Okay, because here you can essentially choose where you want to be. You can choose the amount of capital that you have in the long run. You can't do that, right? In the short run, you can't do that. In the short run, the only thing you can do is to move along one short run ATC curve by either hiring more or less workers. So in the short run, you cannot, let's say, jump from one SR ATC curve from the other. You can simply move along the short run ATC curve you are on, depending on how many machines you have. But in the long run, you can move along a curve, and you can also jump from one to the other simply by changing the amount of capital equipment that you have. Okay, so clearly from this level of output, from 0 to this level of output, you're going to stay on SR-ATC1, okay, because it is the one that allows you to produce at the lowest cost. But then once you reach this point there, if you want to produce more in the long run, you will actually jump on SR-ATC2. So you will use 2 machines, because it is what allows you to produce at the lowest ATC. And again, once you reach this level of output, if you want to produce more, you will get 3 machines instead of 2, because this is what allows you to produce at the lowest possible cost. So overall, boom, 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 this is your LR ATC curve. We say that the LR ATC curve is the envelope, the lower envelope. It's like if it envelopes all the SR ATC curve, okay, the lower envelope. And I can do that with more, okay, same thing. So here, instead of having just 3 choices, 1 machine, 2 machines, or 3 machines, here I have to choose between 1, 2, 3, 4, 5, 6 machines. And it's exactly the same thing, okay, exactly the same process. And you see that, of course, if I add more and more choices, from 3 to 6, from 6 to 10, from 10 to 20, from 20 to 100, this will look like more and more like a curve, okay? Not something like that, but more like just a U-shaped curve. So this is how we built the long run ATC curve from the short run ATC curve. Okay. If you feel like this is going to confuse your students, it's okay to keep it simple, and that's usually what I do. I usually explain this, like what I did there, because I think it's okay. Most of them understand. Just to explain why the SR-ATC is always above the LR-ATC. And usually I just go a bit quick on this, and it really depends. If I feel like my students can really understand, then I describe it If you feel like this might confuse them, it's okay to skip it, or to really, let's just say, stress the key points without giving too much detail. All right, okay, so essentially this is how you can represent it. That's your LRATC curve, just like in the short run, it's U-shaped, but for different reasons. Here it's not U-shaped because we have increasing returns and then decreasing returns. Is U-shaped simply because we assume internal economies of scale at first and then external economies of scale, but we have not yet talked about this. And of course, you could represent the long run marginal cost, which has a swoosh shape, as we say, and that of course will cut the LRATC in its minimum. But this diagram is not very important. They should remember, though, your students should remember that this level of output, the one that minimizes your LRATC, is known as the minimum efficient scale of production. Okay. Then again, you have a few additional slides that you can skip, which is about, again, the relationship between your LR total cost curve and the LRATC and MC curve, but it's not very useful. This example might really clarify things. I called it Ben's car factory. And this is essentially what I explained, really to understand why, or what happens, what is the relationship between the short run and the long run. So let me explain, let me go through this example because I really think that it can help your students to understand. So let's do this. I realize it's a bit late. I apologize. But I really wanted to go through this example. I don't want to rush it. Okay, so we have Ben. He's an entrepreneur and he wants to open a car factory. All right, of course, he needs machines and workers, and we assume that they are substitutes. Okay, so you can replace machines by workers and vice versa. All right. So yes, cars can be produced with either many workers and few machines, or many machines and few workers. And Benz is trying to, like find out, all right, what would be the ideal combination between workers and machines? And he concludes that the best way to combine the resources would be 2 workers per machine. So please keep this in mind. This is very important. Do not forget that. 2 workers per machine. So the optimal capital intensity is 1/2. Okay, K over L, 1 machine, 2 workers. That's the capital intensity. All right. So of course, he would like to, it is when he combines capital and labor in this proportion that he will be able to produce at minimum average total cost. Okay, that's the cost efficient combination or proportion of capital and labor. Any combination that is different, okay, any capital intensity that is different from 1/2, less than 1/2 or more than 1/2, is cost inefficient, which means that there is a poor combination of capital and labor, and therefore the average cost of production will be higher than what it could be. So of course, Ben does some market research. He wants to know, all right, how many units of cars, how many cars should I produce? And he concludes that, all right, I'm pretty confident that I should produce and sell 100 cars per day. Okay. And then he just said, all right, so in that case, I should get 100 workers and 50 machines to produce this level of output. And what we see is that in that case, capital and labor, they are combined optimally. They are combined efficiently, which means that Ben would be able to produce 100 cars at the lowest possible ATC. Okay, because you see 2 workers per machine. So far, so good. Okay, so he gets these 50 machines and he hires 100 workers. Okay, so if Ben's market research is accurate, if the factory actually produces 100 cars per day, then that's great. That's great. Even if we are in the short run, Ben produces 100 cars per day with 100 workers and 50 machines, no problem. So the factors of production are combined efficiently. So yes, we produce at the lowest possible cost. Okay, which means that if we give Ben more time, okay, if we move to the from the short run to the long run, so we basically give Ben the possibility to change the combination of capital and labor, is not going to do anything, right? Because what he has in the short run is already optimal. He is already combining capital and labor in the best possible way. So even if we give him more time to adjust, he will not adjust the input mix. Okay, which means that essentially his average total cost of production in the short run is the same as his average total cost of production in the long run. And this is how we can represent it. This is the LRATC, so the lowest possible cost of production for any given level of output. And this is Ben's short-run average total cost with his 50 machines. And what do we see? Hey, well, that's perfect when I want to produce 100 cars. If I produce 100 cars, my cost of production in the short run is the same as my cost of production in the long run, let's say 20. Why not? Okay, perfect. But, and this is when the story gets interesting. Remember, Ben conducted some market research and he believed that, all right, he would produce 100 cars per day. What if he's wrong? What if instead of producing 100 cars per day, let's say, what if the demand is lower than what he expected? So at the end of the day, he only produces 75 cars per day. Well, in that case, there is a problem because he has already purchased 50 machines. But 50 machines is the quantity of capital that is optimal to produce 100 cars, not 75 cars. But in the short run, he can't change that. He can't change the quantity of machines that he has. So the only way for Ben to reduce production is to use less workers. But the problem is that if we use less workers, that means that we will have too much capital compared with the quantity of labor that we have. So we will underuse the amount of capital. Okay, so yes, he cannot change the number of machines. So if he wants to cut production, he got to lay off some workers. So let's say he lays off 50 workers. So remember that initially we had 100. So now Ben has 50 workers and 50 machines. And this is how we can produce 75 cars per day. But that's not good because in that case, he does not combine capital and labor in the best possible way. There is a cost inefficient combination, which means that he will fail to produce these 75 cars at the minimum ATC. Which means that now if we give Ben more time to adjust his choice, to adjust the quantity of machine that he uses, and assuming that he still has to produce 75 cars per day, then Ben would actually reduce the amount of machines that he has to restore an efficient combination of capital and labor. So perhaps instead of having 50 machines, he would only use 40, and instead of using 50 workers, he would use 80. Okay, so he would get like more workers and less machines. So he could actually produce these 75 cars while combining capital and labor in the best possible way. In that case, Ben would be able to produce these 75 cars at the lowest possible ATC, which means that Ben's ATC cost in the short run is greater than his ATC in the long run, because yes, in the short run, capital was underutilized. We had too much capital compared with the quantity of workers. Because yes, 50 machines was good to produce 100 cars, not good to produce only 75 cars. And this is how we can represent it. Okay, so this is, again, what happens if we produce 100 cars with 50 machines. That works, that's good. But if we produce only 75 cars with 50 machines, you see that the short-run ATC is larger than the long-run ATC. Why? Because yes, we have too many machines. Okay. So now if we give Ben enough time to adjust, instead of using 50 cars, he would use only 40. So we would be on a new short-run ATC curve. And this short-run ATC curve with this quantity of machines is indeed efficient to produce 75 cars. Okay, so essentially we move from A to B and then from B to C. And yes, at point C, when he has, what did I say, 80 workers and 40 machines, then yes, he has the cost-efficient combination of inputs to produce 75 cars. And I can do it the other way around. What if it's wrong? He underestimated the demand for cars. He thought that he would only produce 100 cars, but there are so many people who want to buy his cars. So instead, it's best for him to produce 125 cars. Okay, he wants to meet the demand, so he wants to produce more. But again, there is a problem. The problem is that he only has 50 machines. And in the short run, he cannot change that. So the only way he can produce more is by hiring more people. Let's say that he needs 50 more workers to produce the 25 additional cars. So now he has 150 workers, but still only 50 machines. So same thing, now capital and labor are not combined in the best possible way. The capital intensity is now 50 over 150, so 1/3. What does it mean? Again, is that Ben does not combine capital and labor in the best possible way. Let me just check something. Okay, made a mistake. It should be 125, not 120 here. Oops. Yes. Ben does not combine capital and labor in the best possible way. He has too many workers, not enough machines. He overutilizes the machines that he has. So again, if we now tell Ben, all right, we move from the short run to the long run. Now you have enough time to adapt, to adjust. How many machines do you want? Do you want more machines, less machines, or the same amount of machines? Of course, Ben would choose to get more machines to restore the cost-efficient combination of output. So let's say instead of 50 machines, he would get 60, and he would reduce the amount of workers that he uses, let's say 120 workers. This way, we see that now the capital intensity is equal to 0.5. This is the cost-efficient way to produce 125 cars per day, and therefore, this is what is going to minimize his average total cost of production. Okay, so in the short run, Ben's ATC is higher than in the long run, simply because it does not have the best combination of inputs. Because yes, 50 machines was great to produce 100 cars, but it's not enough to produce 125 cars per day. And this is how you can represent it. So same thing, that's our starting point. This is great to have 50 machines to produce 100 cars, but it doesn't work. Sorry, there is a mistake here. It doesn't work. It's not great to produce. Oops. It's not great to produce 125 cars. I'll fix that later. Okay, so 125. That's not great. We don't have enough machines, and therefore we do not produce at the lowest possible cost in the short term. So again, if we allow Ben to adapt to get more machines, he will get 60 machines rather than 50. So we will be on a new SR-ATC curve. He will essentially jump from one to the other. And this will enable him to produce 100, that's 125 cars at a lower cost of production. Okay. I hope this helps. I like this example. I think this example helps to understand the concept of long run versus short run, the relationship between the two. So if you like it, if you feel like your students might like it, well, feel free to use it. It seems to make sense to my students. Hopefully it's going to make sense to yours. All right, let's quickly finish. There are two things we gotta discuss, but it's rather quick. We need to talk about economies of scale and returns to scale. And it's important to understand the difference. The concept of returns to scale really is about the relationship between input and output. What happens if I increase all inputs by 100%, by 200%? What happens to my output if I double my input, if I triple my input, if I quadruple my input? This is what returns to scale is about. Please emphasize that relationship between input and output. Okay, so we change the quantity, usually we increase, to keep it simple. We increase the quantity of all inputs in our framework, capital and labor, by the same percentage. And we look at what happens in terms of the percentage change in output. Okay, so we compare that. So let's say that we increase all inputs, should be increased by lambda. I will change that, or lambda percent. And we see that, all right, as a result, output increases. You can just replace changes by increases by mu. This is the mu, or mu percent. Okay. What if lambda is greater than mu? Which means, for example, we increase all inputs by 100%. So we double the amount of capital and we double the amount of labor. And we see that as a result, the output only increases by 50%. Okay, 100 greater than 50. In that case, this means that they are what we call decreasing returns to scale. It's just a definition. Okay, it's just a definition. There is nothing to understand. That's just a definition. How do we interpret it? A percentage increase in all inputs will bring about a smaller percentage increase in output. Simple. If they are the same, for example, I double all inputs and as a result, output doubles, we say that they are constant returns to scale. Okay, so a percentage increase in all inputs will bring about an equal percentage increase in output. Simple. And if lambda is smaller than mu, so for example, I increase the quantity of capital and the quantity of labor by 100%, so I double my inputs. And if I see that as a result, my production increases by 200%, so my production triples, then we say that they are increasing returns to scale. So in that case, that means that a percentage increase in all inputs will bring about a larger percentage increase in output. Simple. And that's essentially all your students must know about returns to scale. They don't need to know more than that. They need to know the definition, and they should be able to work out some numerical examples. If you look at my PPT, you have so many fancy diagrams. It's beautiful to watch. It's painful to create. Trust me, I've spent a few hours creating those PPTs. But all of this is beyond the scope of the syllabus, luckily for our students. But again, I could not resist drawing these beautiful diagrams to illustrate the different cases, especially this one. This one was really a pain, like to prepare this diagram. It really took me a long time, but it's beautiful, but it's not useful. So skip that. Do not confuse your students with this. And this takes us to the last topic that we need to discuss, the concept of economies and diseconomies of scale. And we got to be careful because, yes, we should distinguish between internal and external economies and diseconomies of scale. So let's start with the concept of internal economies of scale. Quite easy. We say that there are internal economies of scale when an increase in output leads to a decrease in the long run ATC, okay, not the curve, but the cost. And we will say that there are internal diseconomies of scale. And please, please, I hate it when kids, they write economics of scale, or economic of scale, okay? This is a key word. They are allowed to make spelling mistakes for let's say standard words, non-economic related words, but economies and diseconomies of scale, they are key concepts and students are not allowed to make spelling mistakes. So internal diseconomies of scale, it's when you increase output and this leads to an increase in the long run average total cost. Yes, so essentially you increase output and you move along the ATC curve. If you move down along the ATC curve, that means that you have economies of scale. But if you increase output and this leads to a movement up along the ATC curve, that means that you have diseconomies of scale. So you see that what is very important, because your students might not really understand, all right, what is the difference between returns to scale and economies or diseconomies of scale? It's very easy to explain. Returns to scale, it's about the relationship between input and output. Okay, we change the amount of inputs and we see what happens to output. Economies and diseconomies of scale, it's about the relationship between output and average cost. That's not the same thing, okay? This is what makes these concepts different. Okay, again, there are additional slides about the relationship between returns to scale and economies of scale or diseconomies of scale. You even have a numerical example if you want to have a look at what is the relationship between the two, but I suggest you skip this. I do not print this for my students. Again, it is beyond the scope of the syllabus, but again, if you have students who want to go the extra mile, who are really interested in economics, they want to, get a bit of a head start before university, feel free to print this for them so they can better understand the relationship between these concepts, but it's a bit more tricky. Okay, for let's say our standard students, this is enough. Just say, all right, the LRATC curve is usually assumed to be U-shaped because we believe that at low levels of output, firms benefit from internal economies of scale, and we'll see the causes in a minute. But then eventually there will be a point after what we call the minimum efficiency scale. If they keep increasing output, they will eventually suffer from these internal diseconomies of scale. Okay, so it's like good news, bad news. Okay, right. Now, why? What can bring about economies of scale? How can we explain that if we produce more, our average cost of production is going to decrease? And this is actually quite important. There are many MCQs about that, and this is also something that there are some essay questions and data responses that are about that. All right, the first category of economies of scale is what we call technical economies, which is essentially about the production technique, the production process. Basically, bigger companies, they can use more efficient methods of production than small businesses, simply because they have a larger scale, so they can implement, there are different solutions, so they can implement the division of labor. If you are a very small business, you might not be able to divide labor, and we know that specialization makes your workers more productive. Yeah. So with a higher productivity, your cost might decrease. That's one way you can explain technical economies of scale. Bigger companies, they can use what we call specialist capital machinery. Essentially, they can use more efficient, bigger machines that are also more productive. If you are a very small business, you might not be able to purchase this very expensive capital equipment. It's not worth it for you to purchase very efficient capital equipment because the fixed cost is too high. But for a very large firm, they can use these very productive machines. And with these gains in productivity, they might be able to lower the cost of production. I use the example of a professional photocopier. There are some photocopiers that are very, very expensive, very high fixed cost, but they are very efficient at printing. Then once you have this professional photocopier, you can print every page at a very, very low cost. It's very, very quick. So big businesses might be able to afford these professional photocopiers, and therefore they will benefit from a very productive capital equipment. Small businesses might not be able to afford this specialist capital machinery, which means that the productivity of their capital equipment is likely to be lower. You could mention the law of increased dimensions, but I would rather leave this aside, okay? Especially because I feel like students, they are usually very confused about this. So I think this year, I think I'm not even going to mention it. You have a beautiful diagram. Oh, wow. That explains it. But I think I'm really going to skip it this year. So yeah, you have technical economies of scale, and this is how you can explain it. Then you have, I don't really like this one, but you have managerial economies of scale, which essentially means that as your business grows, you can rationalize the organization of your company. You can divide your company in terms of departments. You can appoint managers whose job is to increase the productivity within each department. You can appoint people responsible for the communication between departments. Essentially, what we mean by managerial economies of scale is that bigger companies, they can rationalize their organization, and this more efficient structure, this more efficient organization can lead to gains in productivity, eventually reducing the cost of production. You can actually hire specialists. In a very small business, you might not be able to hire specialized staff whose job is really about to improve the efficiency of the entire organization. Okay, but as you grow, you can work on that, gain in productivity, and eventually reduce your cost of production. Financial economies of scale is basically the idea that bigger businesses usually have access to a wider range of source of finance, and they can get like lower interest rates. Essentially, because bigger businesses, they are often regarded as safer. It's less likely that they will go bankrupt. So for example, banks, they will be less afraid of giving loans to these bigger companies. So because they see those businesses as less risky, they will be more willing to charge lower interest rates. Bigger businesses, they might even be able to raise funds by selling stocks in the stock market. So yes, that's a wider range of sources of finance. Yeah, so essentially bigger businesses, they can borrow money at a lower cost than small businesses. There is, of course, the element of risk that decreases as the firm grows, less likely to go bankrupt. and the diversity of financial products that they can have access to. A small business cannot sell stocks in the stock exchange, of course. This one is the favorite of many students, purchasing economies. The idea that if you are a big business, you are going to buy large quantities of inputs like steel, raw materials, and therefore the suppliers, they are more likely to offer discounts, okay? So you will be able to purchase raw materials at a lower cost if you have a higher scale of production. Easy. Marketing economies, it's the idea that a lot of your marketing expenses are actually a fixed cost. So for example, if you pay for an advertisement on TV, of course, it doesn't really matter how much you actually sell. The cost is the same, okay? The cost of an advertisement on TV is a fixed cost. It does not really grow with how much you actually sell. So if you sell a larger quantity of output, if you have a larger scale of production, then the cost of advertisement is actually spread over a larger quantity of output. So the average cost of advertisement and marketing in general is decreases as you increase your scale of production. Okay, we can skip this. But unfortunately, there are also some reasons for which a business can experience internal diseconomies of scale. So basically, when we get bigger, our average cost is going to rise. All right, so why? There are a few reasons for which this may happen. This could be about communication. When the business grows, it's more complicated, more costly to communicate, especially between workers. Communication between workers is more complicated. I don't really know why I did this, but why not? This is a diagram that shows how many bilateral communication channels we have. And you see that it increases exponentially with the number of workers. This is just something to emphasize that, yes, as we grow, communication becomes more complicated. And therefore, this is something that can contribute to increase your cost of production, your average cost of production. There might be some wasteful duplication of effort, especially in very large organizations where you may have two people actually doing the same thing, but they don't know each other and they do not communicate. And therefore, you have two people assigned to the same task. They are not working together. So that's a possibility. And of course, it's wasteful, and this might lead to a higher cost of production. A bigger organization usually have different factories, different office buildings, which can lead to higher transportation cost. If you have to move, let's say, raw materials or your inventory from one location to the other, if workers have to move from one factory to the other, you can have higher transportation cost. You may have office politics. So essentially, people that make decisions that are good for them, but not good for the company. You should not really do that in a very small business, because if you do that in a very small business, it might actually go bankrupt. Okay, that's what we call office politics. Okay, you just make decisions that benefit yourself, but that go against the interest of the business, like appointing someone that is not suitable for a position, but someone that you like or someone that you can keep under your control. Why is this more likely to be a problem in a bigger organization? Because as I said, in a big organization, you can do that. Okay, it's not good for the business, but the business is not going to go bankrupt. You are not going to lose your job. If you do that in a small business, then yeah, you might actually lose your job if this causes the business to fail. That's a problem. So basically, you can have people who are not qualified appointed at some responsible for some important tasks in the business. You may have a lack of motivation because, yes, in big organization, we tend to divide labor excessively, and people might not really feel valued. They might feel isolated, not appreciated. The work that they may have to complete might be repetitive. They might feel like they are not involved in the workings of the organization. And overall, this might have an adverse effect on their motivation. And obviously, there are some coordination problems. Managing the organization is much bigger when it is bigger. So there might be some issues where it's more difficult to monitor performance, to make sure that everybody is doing a good job, making sure that everything runs smoothly. All right, so these are just a few examples of what can cause internal diseconomies of scale. Okay, almost there. Thank you for sticking with me. I haven't had dinner yet. I'm really starting to starve. So, but it's okay. In 5 minutes, 10 minutes stop, we will be done. Right. The other type of economies of scale is what we call externals. We see everything that I mentioned here before is basically stuff that happens within the organization. Okay, things that are under the control, under the influence of the organization. The concept of external economies and diseconomies of scale is about the business environment in which the firm operates. It's about the industry, and it's about what happens when the industry grows. So if you have like more businesses, more competition, basically, is this going to be good for you in terms of your cost of production, or is it going to be bad for you in terms of your cost of production? Basically, to rephrase it, if the industry in which you operate grows, is this going to allow you to produce at a lower average cost? Or on the other hand, is this going to, lead to a situation where you produce at a higher average cost than before? If it allows you to produce at a lower cost, then we say that you benefit from external economies of scale. But if the growth of the industry makes you or increases your average cost of production at any given level of output, then you suffer from external diseconomies of scale. Yes, this type of economies of scale, they occur outside the firm. That's why it's external. But within the industry, okay, we still have to be within the industry. And they affect all the businesses in the industry. It doesn't matter how big or small they are, okay? But all the firms in the industry will be affected the same way by those external economies or diseconomies of scale, okay? And unlike internal economies of scale that could be represented by a movement along the LRATC curve, okay, we increase the amount of output produced by the business and we see what happens. Does it lead to an increase or decrease in my long run average total cost of production? But for external economies and diseconomies of scale, the idea here is that it's going to either increase or decrease the average cost of production at any given level of output. And therefore, this is represented by a decrease or a downward shift of the LRATC curve in the case of external economies of scale. So you see that it doesn't matter if you produce a small output or a large output, regardless of your size, regardless of your level of output, your average cost of production falls, okay, at any level of output, external economies of scale. And in the case of external diseconomies of scale, at any level of output, regardless of your size, your average cost of production rises. So that's how we represent external economies and diseconomies of scale. Okay, what can cause them? Yeah, that's what I have there. Yes, so they are associated with shifts, upward or downward shift of the LRATC curve. And yes, sometimes This is why firms, they want to cluster. Okay, cluster means to group together. There are some areas where there are many businesses who choose to locate in the same geographical area, just like the Silicon Valley, because they expect that they will benefit from external economies of scale. So what can allow those businesses to benefit from external economies of scale? When an industry grows, if you have a lot of businesses that have chosen to locate in the same geographical area, this may encourage the government to improve the infrastructures, could be the transportation infrastructures, could be the telecommunication infrastructures. So then all the businesses in this area, they will benefit from this better transport or telecommunication infrastructures. Essentially, if you only have two businesses, two firms in an area, well, the government is not going to consider this as a priority to build good highways, to make sure that they have a high-speed internet, things like that. But if you have 20 businesses in the same area, okay, then it's important for the government to make sure that they have access to good infrastructures. Could be same thing, that this cluster of companies, this group of companies, as the industry grows, it's going to attract some R&D, research and development facilities in local universities. There will be more universities that will do some research that relates to the industry in which those businesses operate. Why? Because if university make research on that, this means that they will be able to train students, and then the students will be able to find jobs. Okay, so if you have like I don't know, businesses that work in the AI industry, let's say in Chengdu, because that's where I live, then it's going to encourage universities in Chengdu to offer AI programs for their students, because then, okay, there is a good connection between research, knowledge, and then the students will be able to work for the local AI companies. Why is this a good news for local businesses? Because they will have access to a large pool of qualified, skilled workforce, which means that it's the HR costs will decrease. It's going to be easy to find workers, and the training costs will also decrease because the workers are already qualified. So this is something that can allow a reduction in the cost of production. And again, if you have 20 businesses that locate in the same area, this is going to encourage suppliers to open factories closer. So this is one way to reduce cost of production, cost of transportation, and therefore, again, overall, reduce the average cost of production of all businesses in the industry, because they don't have to ship their supply. They don't have to buy their supply from another country or for thousands of kilometers away. They have a supplier nearby, and therefore the cost of supply can decrease. And again, the availability of a pool of skilled labor, that also relates to the fact that you will have more and more local schools, colleges, universities training the local population to give them the skills that are needed by these companies, simply because this is one way of ensuring that the local population will not be unemployed. And businesses are very happy because there are a lot of people in the area that have the skills that they need. So with a lot of qualified workers, they might keep wages low, okay? Because it's easy to find qualified workers, so they don't have to raise wages so much to attract qualified workers. And finally, what can lead to these economies of scale? So now we have the industry that grows, and this is a bad news for all the businesses. This increases their average cost of production. Could be something as stupid as traffic jams, yes. If the infrastructures do not improve, if the transportation infrastructures are, let's say, overutilized by all the businesses, let's say you have 20 businesses and just one small road, then you may have some problems with traffic congestion, Why is this related to the cost of production? Simply because it can lead to an increase in your transportation cost. Okay, maybe not the best possible example, but why not? This one is more clear-cut. If the industry grows, this means that there will be an increase in the demand for specific skills. Okay, so there will be an increase in the demand for labor in some labor markets. And with a higher demand for labor, this means that the wage might actually increase. Okay, basically, you have more firms who produce; they are competing for workers. So this might push wages up. And if you have an increase in wages, then of course this increases the cost of production. This could be the same thing for land. What I mean by land really is like really places to build a factory, something like that. You have more farms competing to purchase land to build factory, and this can increase the price of land. And again, this is a bad news for businesses because they will have to pay a higher rent. And that's about it, really. Okay, I'm done. Are you still there? Yes? Are you still alive? We are all here, yes. Okay, questions? Yeah, thank you. Good session, long session though. Do you think the sessions are too long? Maybe, right? At least you definitely have value for money. Yeah. Right, maybe for macroeconomics, because I can't really change the content now that everybody has already signed up. But for macroeconomics, I think I will reduce the content for each workshop so we can keep that shorter and a bit less intense, because it's been like 2 hours, 40 minutes. It's intense for me. It's intense for you. So of course you'll still have the video recording, but yeah, that's a lot of content. So for macroeconomics, I think I'm just gonna try to like reduce the amount of content covered within each workshop. Any question, any feedback, anything that you would like to share with me before we conclude tonight's workshop? So again, remember that in a couple of days, you will have access to the resources, summary, list of definitions, updated PPTs, video recording. Of course, you'll have it tonight. So wait a little bit before you download these documents and print it for your students. Okay, just I will post a message in the WeChat group just to let you know when everything is ready. Okay, no questions? All right, then let's stop here for tonight. Thanks everyone for joining. Have a lovely evening. See you tomorrow if you attend the AS session. Tomorrow we'll talk about elasticities in AS, and next week for A2, well, we'll talk about many things. We'll talk about revenue curves, profits, the objectives of firms and the growth of firms and the survival of small firms. It's a lot, but it's very easy, so we'll be able to move very quickly. Apart from the video recording, you don't need a VPN for anything apart from the video recording, because the video recording is hosted on a website that you can't access without a VPN, but everything else can be downloaded without a VPN. Should be fine. Okay, have a nice evening, everyone. See you tomorrow or see you next week. And yes, I will grab some food right away. Good night, everyone.